Hello, everyone. Thanks for joining us as we present a brief summary of our greenhouse gas emissions study related to the embodied carbon impact of using mass timber in the structure of a building. We enjoyed a collaboration with our structural engineers at Bureau Happold, the architects at Generate Technologies, and forestry advisors at Oliphant. I'm Julie Janeski, a principal at Bureau Happold, and I'm very pleased to introduce my colleague, Aurora Jensen, our lead lifecycle assessment analyst, to share our work.
Hi, everyone. So we're going to start by walking through the various design options we compared in this LCA. So starting on this page, we're including our two reference cases, and these are meant to represent typical practices in the construction industry. So here you can see the names we'll be using throughout the study, a short description of the structural systems involved, comment on the grid spacing. These are pretty typical for our reference systems, and then a note about what it took in terms of encapsulation to meet fire rating requirements. And down here you can see kind of across many options, qualities that draw them together. So here both of these options include concrete cores. Moving to the timber options, we have from left to right a series of post and plate and then post beam and plate structural approaches. And here you have varying grid sizes. All of these options include concrete cores and different approaches to encapsulation for fireproofing. Note this exposed for char layer in timber 5. On this page, you can see a number of additional timber options. So this was 9 in total. And here options 7 and 8 really distinguish themselves as being slightly different, more unusual approaches, tighter grid spacing. These are really cellular structural approaches. Timber 9 here is our only hybrid option. Both of these cases here have concrete cores, and then both timber options 7 and 8, because of this tight grid spacing, required a steel frame podium at the ground floor in order to accommodate retail program. And that's noted here in our table for functional equivalence. So that was a design move that was really required to make these options comparable, apples to apples. So in addition to controlling for program, we also were very careful about the level of development of the structural system, the fire rating requirements, the thermal performance, and the acoustics. So these are equivalent across all the options. And we also applied the same system boundary in the study. So this system boundary is really derived from our tool, which was Tally, which is a Revit plugin for LCA. And we included the biogenic accounting feature using Tally. Here you can see our building elements. So we included foundations and structural systems, as well as the enclosure and selective interiors. So this is interior walls, encapsulation for fireproofing, and flooring layers that are needed to achieve this acoustical rating. So a brief introduction to our results. So on the left, you can see the full building comparison. This is expressed in global warming potential, and the variety of performance between the timber options. These are expressing the reduction from our reference case 1. And this is our, steel framed system. So 14 to 52% is the range in full building comparison, and 31 to 73% is the range if you isolate that structural system. Looking at this performance in more detail and breaking out the portions of the building that contribute to that impact, you can see the reference cases on the left. This is the steel and concrete systems. And then from timber 1 through timber 6, you're seeing those more typical post beam and plate approaches where you're still maintaining those concrete core walls. Timber 9 is that hybrid system with concrete core walls and steel structure. And then you have options 7 and 8, which are those more cellular approaches. And we'll get into those in more detail in the next slide. One thing to note before we advance is we're going to be using a metric called carbon avoided, which is really just a subtraction of this reference case and the option under study. So kind of a theoretical quantity of how much carbon would be saved by building timber 1 instead of the reference case. It's really an imaginary quantity in some ways, but it's informative as well. So in the left, you can see that calculation of carbon avoided, and then also a carbon stored quantity, which is a way of understanding the temporary duration of carbon storage in those bio-based engineered wood materials in the building. And you can see timber 7 is really exceptional due to its high quantity of timber from that cellular structure. And then timber 8 has a significant amount of carbon avoided, but it's much more selective in its use of timber. So you can really see that in timber, in carbon stored, it's clustered with the other options. So in conclusion, designing with mass timber generally yields lower embodied carbon overall compared to our reference cases in this study. Engineering out the concrete core walls really led to the most significant reductions observed in this study. And you can see that visually in this expression of mass here. So you can see where the concrete quantity of the total building mass really drops almost by half just by engineering out those concrete core walls, which is really kind of lovely to see. In addition, using the larger grid spacing and exposing the timber members leads to the best of the options T1 through T6, which is this more typical approach, and that's timber 5. And then finally, fireproofing and acoustic equivalence really didn't unduly burden any of the timber cases, so shouldn't be used as a reason not to build with timber.
We also wanted to acknowledge that there are many ways to continue our work with further development of either detail or expanded scope. Some examples of that might include additional detail around specific timber once it's available and the variability of the reference cases with additional optimizations or sensitivities for steel and concrete, and the scope of the study potentially expanding into systems as well as other comparisons around items like operational carbon. Thank you again for joining us, and thanks to the conference committee for the opportunity to present our work. Please do be in touch with any questions or if you'd like to collaborate.